In this chapter, you'll learn why GraphQL is the better alternative to RESTful APIs. Over the past decade, REST has become the standard for designing web APIs. It does offer some great ideas, such as stateless servers and structured access to resources. REST itself actually is a strict specification of how a server has to expose its data to the clients. However, today almost all APIs are labeled to be RESTful APIs, even if they don't adhere to that specification. REST APIs have shown to be too inflexible to keep up with the rapidly changing requirements on the clients that access them. GraphQL was developed to cope with the need for more flexibility and efficiency in client-server interaction. It solves many of the shortcomings and inefficiencies that developers experience when interacting with REST APIs. To get a better feeling for the differences between GraphQL and REST, let's consider the example of a simple blogging application where we want to show a user's profile screen. On that screen, we want to show the user's first name. We also want to render all the posts that the user has ever created. And finally, we also want to display the last 3 followers, because in our blogging app, it's possible to follow each other to see the news whenever a user publishes a new post. How would we tackle this particular screen with a REST API? In REST, we would typically have 3 different endpoints that would allow us to fetch the required data. The first endpoint is the user's ID endpoint, where we can obtain the information about one particular user that's identified by the ID that we are passing in the URL. Then we would also have a /users/ID/posts endpoint that would return all the posts for a specific user. And finally, we also would have the /users/ID/followers endpoint, and here we would get back all the followers of the user that's identified by the ID that we're passing in the URL. So let's walk through the flow that we would need inside the application to fetch all the data that we need to display the user's profile screen. The first step would be to fetch the data about the particular user. Here we would hit the /users/ID endpoint to get information about the user that's identified by a particular ID. The server would respond with all the information that it has currently stored about that user. But notice that at this point, we are not only downloading the user's name that we want to display inside the application, but we are also downloading additional information that at this point in time is not relevant to the application, such as the user's address or the birthday. By downloading this additional data, we are putting weight on the user's data plan with information that's actually not required in the app. This is not a desirable situation. But now at least we have access to the user's name and can display it on the profile screen. The next step for us is going to be to download all the posts of the user. And for that, we're going to use the /users/ID/posts endpoint that we're hitting with the user's ID. This time, the server returns all the information about the posts of that user that are stored in the database. And notice again that we're downloading a lot of additional information that's not really relevant to the app, because we really only want to display the title of each post. But again, at least we've got access to the post's titles now, so we can render them inside our application. And finally, to implement the last requirement of our profile screen, we have to hit the /users/ID/followers endpoint to fetch the followers for the users whose profile screen we're showing. We're sending a GET request to the API again, and the server responds with the information about the followers. And notice again, we're downloading a lot of additional data that we don't actually want to display. And we actually also only want to display the names of the last 3 followers, but there might be hundreds or even thousands of followers associated with that user that we're now also downloading. But again, we can at least render the information inside our app. Now, you could of course design your API in the way that it exposes the data in the way that it's more appropriate for that particular profile screen, but this is also not really the ideal way to go. In today's application, you want to be able to iterate quickly on your designs and experiment with different features. If you had to go and adjust the API every time you update the design on the front end, then you're not able to iterate quickly on the product. So how can you solve that same situation with a GraphQL API? With GraphQL, you would only have a single endpoint that would be used by all the different clients that want to retrieve data from the server. So with GraphQL, you would actually only send a single request to the server, and the server would respond with all the information that you need. The way how this works is by sending a post request to the server, where you in the body of that request you include a query that describes all the data requirements of the client. So in this case, we're asking for the user with a particular ID, and then we can specify all the data that we want from that user. So we want the name of that user, we want to have the titles of the posts of that user, and we want to have the names of the last 3 followers. When the server receives that query, it will process and resolve it to fetch exactly the data that's specified in the query and read it from the database. It'll then package it up into a JSON object that it just returns to the client. This is what the response will look like. So the root field in this JSON object is called data, and that's what's specified in the official GraphQL specification. And then it returns just all the information that you want to display in the user's profile. So exactly what we specified in the query is now going to be returned to the client, and we can use all that information to render it inside our application on the profile screen. So now that we have a better understanding of the technical differences between GraphQL and REST, let's move on to discuss a couple of other high-level differences between them and see what other benefits GraphQL has compared to REST. So first, we eliminate the problem of over and underfetching. And these are exactly the problems that we just encountered in our example scenario. So the problem of overfetching means that we're downloading unnecessary data into our application and thus exhausting the user's data plan with information and data that's not required at this particular point in time. The problem of underfetching, on the other hand, means that a specific endpoint doesn't return enough of the right information, so we have to go and send multiple requests. And this could go and escalate into the n+1 requests problem, which means that we have a list of items that we fetch from the server, but for each of these items, we need more information that we get from a dedicated endpoint. So we actually have to send one additional request for each item that we downloaded initially just to get that information. One way how we could have solved the problem of underfetching in our previous example would have been by exposing an API endpoint that returns exactly the data that was needed for the profile screen. This is a common pattern in REST APIs to structure the endpoints according to the views that you have inside your application. This is handy since it allows for the client to get all required information for a particular view by simply accessing the corresponding endpoint. The major drawback of this approach, though, is that it doesn't allow for rapid product iterations on the front end. With every change that is made to the UI, there is a high risk that now there is more or less data required than before. Consequently, the backend needs to be adjusted as well to account for the new data needs. This kills productivity and notably slows down the ability to incorporate user feedback into a product. With GraphQL, this problem just doesn't exist anymore. Thanks to the flexible nature of GraphQL, changes on the client side can be made without any extra work on the server. This enables faster feedback cycles and product iterations. GraphQL allows to have fine-grained insights about the data that's requested on the backend. As each client specifies exactly what information it's interested in, it is possible to gain a deep understanding of how the available data is being used. This can, for example, help in evolving an API and deprecating specific fields that are not requested by any clients anymore. With GraphQL, you can also do low-level performance monitoring of the requests that are processed by your server. GraphQL uses the concept of so-called resolver functions to collect the data that's requested by a client. Instrumenting and measuring performance of these resolvers provides crucial insights about bottlenecks in your system. Another major benefit of GraphQL is its type system. GraphQL uses the strong type system to define the capabilities of an API. All the types that are exposed in an API are written down in a schema using the GraphQL schema definition language. This schema also serves as the contract between the client and the server to define how a client can access the data. Once the schema is defined, the teams working on the front end and the back end can do their work without further communication, since they both are aware of the definite structure of the data that's sent over the network. Front-end teams can easily test their applications by mocking the required data structures. Once the server is ready, the switch can be flipped for the client apps to load data from the actual API. In the next chapter, we'll introduce the core concepts of GraphQL and talk specifically about GraphQL queries, mutations, subscriptions, and the schema definition language.